Hello guys, in this video we will do one example of direct proof and one example of contrapositive. So let us start. This is the first question. Prove that if A is even, then A squared is even. Now we want to prove that if our A is even, then our A squared is also even. Now we will say if A is even, then what do we know about even numbers? If A is even, then our A can be expressed in terms of 2 multiplying something, right? So our A can be expressed as 2m, where our m is an element of what? Of integers. Now this is what we have. From here, we know that our A is equal to 2m. So A squared is now equal to 2m all squared. Then we simplify. What is 2m squared? It is equal to 4m squared. Now our a squared is equal to 4m squared, but we want to express our a squared in terms of 2 multiplying something. So we will have 2 multiplying 2m squared. This is what we have. Then from here, we can say let maybe p be equal to 2m squared, where our p is an element of integers again. Then we can substitute p. It will be equal to what? Equal to 2p. A squared is equal to 2p. A squared is equal to 2p. We know that 2p is an even number, so a squared is also even. We have proven that if a is even, then a squared is also even. Now let us move to the second example. We are moving to the proof by contrapositive. Now we want to prove that if a squared is even, then a is even. If p implies q. Remember, if p, then q. This is contrapositive. Now we will say if not q implies not p. We will say we want to show that if a is not even, then a squared is not even. We say not q implies not p. This is what we say if we are proving by contrapositive. So from here, we can say if our a is not even, if a is not even, okay, if a is not even, then our a can be expressed in terms of the opposite of an even number, which is odd. So then a is equal to 2m plus a 1, where m is an element of integers. Now this is what we have. Then from here, what do we say? We will say since we have said that a is equal to 2m plus a 1, now we'll say so our a squared is equal to 2m plus 1 all squared, right? Then if we simplify to m plus 1 all squared, it will give us 4m squared plus 4m plus a 1. Then we will take out the common factor, 2, not 4, because we want to express it in terms of 2 multiplying something plus another number which is odd. So it will be 2 multiplying 2m squared plus 2m plus this one. Now we have 2 multiplying something plus a 1. We will say let p be equal to 2m squared plus 2m, where p is an element of integers. So our a squared is equal to 2, we substitute this with p, 2p plus a 1. Now we know that 2p plus 1 is odd. Therefore, our a squared is not even. Our a squared is not even. So we have proven that if a squared is even, then a is even by using contrapositive.